of the day on this stage. So, Omid, are you there?
Yeah.
Bonjour, Omid.
Bonjour.
So, directly from Paris, are you?
Yeah, sure.
Yeah,
I'm not in
okay.
center of Paris, but I'm
Yeah,
I'm
but
not far.
like, you know,
Yeah, I'm there.
somewhere where you almost see the Eiffel Tower is, Paris for
I
us.
can try that in 10 minutes.
Okay, good. So your slides are up and you're going to talk about event-driven design, and this is related to real estate industry, isn't it?
Yeah,
Thank you, and you're welcome to start.
thank you. Hello, everyone. I'm Omid. Today we will talk about event-driven design and serverless, and we will focus a bit at the end of this talk on the observability. To present myself, I'm Omid, and Omid Eidivandi. I'm a lead engineer, technical lead engineer at SeLoger Group in France. It's a real estate platform, online real estate platform, and we're focusing to standardize and make our API ecosystem international. And for about 4 years, I'm working with them, and our challenge is modernizing our monolithic or legacy systems or the distributed system to the enough resilient performance and cost-effective and secure solutions. So my principal points are stay on 5 pillars of application development and software engineering: the cost, security, performance, operational, and resiliency. To have a brief review on event-driven EDA and what's happening in EDA, event-driven design have 3 components, 3 parts. Basically, the producer and the router and or processor and the consumers. And what's the goal of event-driven architecture? To decouple any component and keep any component bounded in the owner of its bounded context, and make the component enough resilient, and try to reduce complexity in a business perspective, and make our solution enough adaptable. So any change, any decision to which will lead you to redesign or change part of your design, it's as fast as possible without a huge impact in your already production environment. And basically, there are statelessness. So I will have a look in 3 components briefly. So the producer is the part that will send you the brute message. It's not yet an event. So they don't care about the processing. You will guarantee the processing. They send you the message and ask you, and they just respect your API contract. What about your contract is it SeLoger Open API or API sync documentation? Everything it is, it will be well documented and represented by to your consumers. And they don't need a response as soon as possible. So we get it. The producer and router get it asynchronously, communicate asynchronously, and just we say him, we got your message, and they are totally decoupled. And the router or processing add some value to that message and process that event and transfer that event to the valid entity. So that's your business domain entity. And many dependencies are not, like some HTTP calls, some database verification, some kind of this infrastructure dependencies. And the consumer basically are subscriber to your processing system. They, they're not waiting for the message. They're waiting for the state that you added and the evaluated state that you enriched that message and you added the state to the event. So they need also a consumption contract, like the producer. They need some consumption contract to trust and it need be well documented again. So in event-driven architecture, in any architecture, in distributed architecture, we have two kind of dependencies: the loosely coupled dependencies and the highly coupled dependencies. We focus firstly in loosely coupled dependencies. Just an example I get in the slide. The order system, a requester will ask you, I want to order this product, and you will call retail system. So if retail system or infrastructure or network is down, you will be lost. So we make a queue, we make a messaging system between the two components, two web services, two systems, to be able to synchronously communicate together. So order system will say the requester, I'm okay. Uh, we can avoid network failures or loss of orders, or in terms of user experience, your requester don't care about your failures. Just say you, I need this product, and you get it. Okay, I got your request, and I will treat that. By the way, and now imagine that side of retail system we have a second dependency, an email system. So we process that order, we push that in the queue, and retail system will get that retail that event, and email system need as well. But imagine that the retail system is a bit under latency. So email system will fetch that event, and he will process that, send the email, and finally, so he will call back to the your message broker and say, I treated that event. Normally, theoretically and technically, the message broker will remove that event if the treatment is okay. So what's happening? What's happened here for retail system? If it came back after 1 minute or 2 minutes, that's lost. That here we are focusing on the we need some ownership of that event. The event ownership of basic event is the order system, but I will give the permission to email system and retail system to keep their event in the temporary storage. And just a funnel design. The funnel design, I replaced the message broker, the simple queue, to a publish subscribe broker. And here we added two queues, each queue under ownership of its proper system. And the publish subscribe, he will push as the event arrive in this broker, he will push that event to the both of the queues. And the email system or retail system are really independent to come and fetch them and treat them as they want. We will have some latencies, maybe, if retail system will become healthy after 30 minutes, but we will never lost that productivity or event. So this is the solution, simple solution, but we are decoupling the ownership, and this is a strategical or organizational decision. And when we talk about highly coupled dependencies, we have some kind of highly coupled dependencies like product system, or the system need he get a message, for example, with a product reference, but he needs to know what is the actual state of this product. So it's mandatory to call the product system. So here we cannot add the state to that event and push that event to the retail and email system without these informations. So if the network failure, any kind of failure will cut this connection between order system or product system, or again, or requester is impacted negatively. So some patterns, kind of callback pattern, can help us. Order system take that event and he just asynchronously inform the product system that I need some information, and he will give the product system a tokenized ID, a token, a unique identifier. That's my identity, and I need this information. And product system, after it in real time, or after 1 minute, after 2 minutes, I don't know, he will be able, when it's able to process that, he will call back to order system, giving him back the identifier, and the identifier, and also side of that, the response, the product information. So the order system can get, because when we call another system asynchronously, we need to stop our process and mark our execution or order as paused, or stopped for the moment temporarily. And when product system gets back to us, we will just resume that execution to the running state, and we will continue or to push that event to our dependencies like email system and retail system, and whatever will be behind them. And there is another pattern than create transfer state. Create transfer state is, till now, we talked about the finite design or finite pattern to resolve the problem of dependencies, and kind of this is the loosely coupled dependency part. But here, till now, the order system was the owner of the original event. But here, he's the consumer. He will subscribe to the product system, and product system will push any changement in the state of the product, new product, add in stock, and whatever is in its bounded context, he will push all that event to a broker, and the order system will subscribe. And as it gets the event, any kind of event, he will evaluate that event and push it to its local database. And so order system can treat for the next time, can treat the order which is ready there, well, in real time, without needing to call to over wire to the product system. And the last chance is cache system, cache pattern. You just basically add a cache system as elastic cache, or any kind of, or Redis, and whatever is the kind of cache system, you can make it possible to improve to cut your dependencies and improve your performance as well. And till now, we talked about how to decouple and how to decouple or components or systems, and let them to be owner of its proper processing, and make any part of business resilient and reliable. So retail system will guarantee this process, and email system as well, and order system as well, and product system as well. But what's happened? What's happened if these failures in the order system or retail system or email system continue failing for a long time? We cannot accept 10 times downtime or in the day. So what's happening? We are doing auto scaling, horizontal scaling. We will add the virtual machine instances, servers, and with the cloud provider is really easy to do. But what's really happening? Any infrastructure to be up take time. So if you imagine that your peak load will be 1 million requests per second, you're ready for that. But if for a Friday holiday, Friday, I forgot the word, but for Friday day, you got 2 million requests. What's happening? You're not ready for that. You're not ready for that, because you're responsible to configure all of this. And this is not so comfort in a long term, in a maintenance point of view. So view serverless to give all these responsibilities to serverless providers as AWS, Azure, or functional service providers, or your private cloud. Okay, I don't know exactly, or IBM, I don't know. So serverless, the serverless solution is auto-scaled, is enough secure, it's auto-managed, as it's business-centric, and is again stateless. So the problem that we was facing was the downtown event system or retail system. This is manageable by your team, by the investigation, but it's not avoidable. So just instead of running one container as a server and a virtual machine, or 3 or 4 or 5, let email system or retail system use the small containers when you need it. We don't care about running container for a long time when you don't need it. We avoid, we consider cost, but behind that we're considering the environment sustainability. And till now, for any event, a new function will be raised. The function basically will be short-living, but it will not be deconstructed as soon as you finish treating your event. No, they will keep it aside for you for example 15 minutes or 5 minutes or 2 minutes, I don't know. That's based on your configuration in any code provider site. And the next event, if your container is ready again, yet he will it will use that. And if it's not ready, if it generally reinitiate a new container. So in serverless, what you need to consider that the functions, you're not free to run the long time scenarios in a function. The timeouts are limited. You're not able to have a function for 20 hours in the Azure or in AWS or in any GCP or others. And take care of your shared context because your shared context can impact your business part. And take care of concurrency. And you cannot have more than a limit, or you can configure it, but this need to be considered based on your situation, your application, your service, that you know your concurrency limits, your needs, and you have to take care about that. And your cold start. The cold start is only when you ask to have a function and when that function is ready. So in this part, you need to monitor and experiment that. And now how takes your function to be ready. For example, if you get that your function is has an initialized time of 8 seconds, you have to solve things because it's impacting your business, and you have to maybe change your memory configuration and CPU configuration to achieve that goal. And basically, functions are based on memory configuration. And based on configuration, originally they will give you a predefined CPU course, vCPU. And when talking about EDA and serverless, use a small function. It's highly recommended, and correlate all these events, and take ownership of your retry, and keep your failed events in the DL queue for analysis and retry later. And keep track of service errors. Any developer in in Microsoft or AWS or GCP can do the failures, and we're not the perfect ones in the world. So take care of the service errors and throttling, And finally, use centralized monitoring dashboard. And when we use serverless, we prefer to use the managed services as managed broker or cluster brokers or serverless databases, NoSQL databases, and physically partitioned databases, and also logically partitioned databases to avoid any loss of performance or failures cause of dependencies. And don't write the multi codes or in the function or the serverless functions, and avoid using serverless and EDA when you don't have a defined bounded context. In GCP, we use the EDA for about 3 years and 4 years. I don't remember exactly. And we have three components: the ingestion part, we received the events from the producer and the message from the producer, evaluate them, and verify just the validity of the message, and push the broker. And this broker has some subscriber, and the principal subscriber is the processing part. A processing part will look at that event and enrich some information or classified information. Classified is real estate announcement. Yeah, we get the price, we get the information that we need to process that, and also customer or professional customer agencies information to communicate with them, some maturity data from our data platform, and finally we have another broker and publish subscribe again, publish subscribe broker, and our distribution part with fetch that evaluated event. It's a valid entity, and he will push that event to our lead database. The lead is contact me request that we're communicating in this platform, the internet user with a professional. So we will keep them by different channels to communicate together. And here in distribution, we have an API, a serverless API, and also we have a push system which is used by our internal teams. And observability. Till now, we was talking about EDA and serverless. We was decoupling everything. We was focusing on distributed design, but we get worse in terms of complexity. We are decoupling a lot because we leave the small APIs, small portions, small components to treat well, to guarantee the functionality, the processing. So we need to decouple everything. But how we will find a failure in one part? In distributed, in serverless and EDA, we use different kind of infrastructure: the gateway, the public subscribe broker, the message broker, the databases, the serverless functions, and all of this kind. Also, state machines, also load balancers behind that, and all of this. So any of these kind of infrastructure components have specific characteristics. In a database, you can save anything that you need. For example, your request ID, your source ID. But what's happened in other type of infrastructure that that's not so complex, but it's a challenge, a mental challenge that we will find a solution for. So here I have a lot of processes. I have, for example, process G and process H that are highly coupled to process that they're highly coupled, and I have process A that is a decoupled process that is communicating just asynchronously with the other parts. So what's happening when we bring all together? So process A push request to the process GD, and yeah, it will continue. And what's happened if any part of system fails? Where is the red point? I cannot say you. I cannot say you without observability, without a well monitoring system. So observability maybe is a cross-cutting concern in an API or application point of view, but in the organizational point of view is one of the must that you cannot avoid that. Imagine that any part of system is managed by one team. You have any issue, what do you want? Any team, one after another, he will debug its code, its application, its API, its any part of system to get the response. And in monitoring part, we need analysis, detection, resolution. And in analysis part, we need to correlate all the systems. We don't have enough time. Yeah.
Yeah, I was going to say that we have to stop now. Sorry, I
No,
need.
okay, don't worry about that.
Yeah.
I will try to share my slide after that. If you have any question, you can join me.
Yeah. Okay. So I don't think we have any questions for you, but if the people can see your slides and contact you, then I think that would be fine. And thank you so much, Omid. I think that was a very, very thorough presentation of all the possibilities of what you can do and what you should think about in event-driven architecture. Thank you so much.
Thank you again. Thank you.